number that was named after him, and it's actually called E because what does his name start with? An E. Yeah, he got his own number. He's like the only mathematician to have their own number. I don't think anybody else has their own number. But it's his baby. It's the natural number, E. He talks about it being what's called a natural base. That's kind of funny. You guys know what base you were taught math in? Yeah.
What are the bases?
You were taught base 10 math.
Okay.
Because you count to 10 and then you start over. That's base 10. Base 6 was a very popular base, before Christ. Base 6, base 16 is still used, hexadecimal, stuff like that. There's different bases in mathematics where you count differently. But he had the idea of what's called a natural base, E. It's a base E system. But anyways, he defined the number E to be the limit as n approaches infinity of 1 plus 1 over n. And we know it's about 2.718281, blah, blah, blah. Now, he lived in the 15th, 16th century, and he actually calculated this out to something like 300 decimal places. So, the idea is as n gets bigger, you get closer to this, okay? So, if you think that E is about 1 plus 1 over 1,000 to the 1,000th power, you just type that in the calculator, and it will give you an approximation of E. That's what Euler defined it to be, by the way, and that's what it is. So raising that to the 1,000th power, which means you write it 1,000 times, only gets you accurate to what? The second decimal? You got this thing on hundreds of positions. I have no idea what he used as an exponent. You guys understand to raise something to the 1,000th power, you write it how many times? 1,000. I don't think he had much to do. Anyways, it's his baby. He made it. He got to name it. These are the applications of it. Some of this we do in Algebra 2. We will do growth models in Algebra 2 at UZ. We'll use decay models in Algebra 2. We'll do savings models. We'll do a logistics model. Actually, today we'll do a logistics model. And we will do just a touch of thermodynamics. What's thermodynamics? It is actually, air conditioning is thermodynamics. It really is. Thermodynamics deals with temperature changes. So yes, HVAC is technically thermodynamics. All right. Start off with working with it. Oh, by the way, just as a refresher, we actually push the E button before Christmas break. Try and find the E button.
It's above the N.
What is it?
Found it. Above the N.
Above N?
It says IN.
It says LN. Natural log.
LN.
Second natural log, and your calculator knows what E is. If you want to know what E to the first is, you can just type E to the first. It's just a number, right? This isn't a letter. This is a number now. Calculator knows where it is. Now, that being said, don't be the kid who types in A in a calculator. I'm not asking what A to the fourth times E cubed is as a decimal. I'm asking if you know how to work with exponents. You were going to type in E to the fourth times E cubed, weren't you?
No.
Yes, you were. So are you. What is E to the fourth times E cubed?
E to the 7th.
E to the 7th. Not everybody knows that, so it's worth talking about stuff we're supposed to. How'd you know it was E to the 7th? You multiply stuff with exponents, you add them. X to the A times X to the B is X to the A plus B. Feel like that's on your form quiz tomorrow. Feel like it is. And 4 plus 3 is 7. You get to use the same property on B, don't you? And then maybe another one. So what's 2e to the negative 4th times 12e to the negative 3rd? 24e to the negative 7th. Does anybody need an explanation on that? It's the same deal, like terms, we had exponents, -3, -4, -7. Is it done?
No.
Why is it not done?
Because the exponent's negative.
Because the exponent's negative. So something else that's on your form quiz is x to the negative n. 1 over x to the n.
And that one,
63.
No, we're not done with this one. We gotta finish it, right? What's it gonna look like in its final form?
1 over 24.
1 over, huh? Wrong!
24 over each. Imagine you choked.
Yeah, and of all the classes today, only one of them actually told me the correct answer in the first place. So Thor up here made the mistake that a lot of kids do. A lot of kids, if they see that negative exponent, they just shift everything to the bottom. What's 24's understood exponent? Is it positive?
Yeah.
Yes. Is it supposed to move? No. Way to go, Thor. Don't cuss. Don't cuss at him. You better said spit.
Huh?
Did you say spit?
Yeah, definitely. Not good language. Yeah.
All right, there's 2 rules that this one uses. Everybody know the 2 rules that C uses? There's 2 rules it uses. I understand you don't necessarily think you need the rules when you have numbers to read, but there's 2 rules it uses. What's one of them? One of them is AB to the x, which is A to the x times B to the x. Anybody know the other one? Talked about it yesterday. Feel like I did. Talked about it for a couple days in a row now. It's this one. X to the A all raised to B. What's x to the A all to B? X to the AB. It's both of them. For one, you give both pieces of 3, right? 10 cubed. But when it comes to the E, which already has an exponent, you have to use multiplication. Multiply those pieces together. Everybody in this room will know what 10 cubed is. 1,000. You put 30, huh?
So I definitely did.
I've had those days too. What's e to the negative 3x again cubed? E to the negative 9x. I bet you want to do something with that, don't you?
Flip the E.
You might see people teach that way. It's because they never took the course after, or they forgot everything about the course after. The course after Algebra 2 would be pre-calc and calc. But in pre-calc, you might be tempted to move the exponent. In calculus, you wouldn't. So I don't know if you plan on taking calculus class one day, but since this is a variable, it's not a number, is it? You can move it, but you shouldn't. And you'll never understand that until you actually take a calculus class. Take calculus, you understand why I'm telling you you shouldn't move it. It can be moved, you just shouldn't. That being said, the people who make your test at the end of the year, who knows what they're going to do. You understand that? Well, sometimes they make tests to see if students understand how to manipulate things. Not necessarily what they should and shouldn't do. Do you know how to manipulate? You can move it. I wouldn't. That's where we'll leave it. You could write it as 1,000 over e to the 9x, though. Do you understand that? But you don't need to. D ought to be easy. $24 over 4. Any takers? 6. Good. E to what power? 4th. A lot of y'all being quiet. Does anybody have any questions on that? I don't actually mind going over it. Hopefully we understand 9 minus 5 is 4. We used a rule there too, didn't we? What rule was used there?
Divide 2x.
X over A.
There you go, x to the a over x to the b. And you're right, you divide, you subtract. X to the a over x to the b is x to the a minus b. You have to know your rules of exponents, kids. You have to know them. You have to. Why they're called rules. I changed G. I think you have a e to the 3x minus 6. I made this. You have a 7, right?
Yeah.
I made it a 6. What's wrong with this page, Chris? Does it make you want to puke?
Yes. No.
So it was a good workout, right?
Yeah, but I actually understand the
No.
work.
All right, first up is E.
Multiply it by, raise it.
That has come up all day. Kids want to square this thing. That works in equations where you have equality, because if you square the left and you square the right, you would still have what?
Equality.
Equality. This does not have equality, does it? If you square something, you literally change it. Do you understand that? You can't square it. I'm not the first idiot to say that day, not going to be the last either. What else you got? I'm joking, by the way. Charlotte, you don't know me. I say a lot of things I shouldn't. Don't think anything of it. I just talk crap all day. That's who I am. What else you got?
Just put it to the 1/2 and do that one thing.
3 over 3!
I thought you distributed first.
Why?
Because it's next to the parentheses.
Why would you waste your time doing that when 3 over 3 just cancels?
I'm sorry. Stops anybody? Oh, and then now you just, okay, I haven't actually.
That actually drops the need for the parentheses in the first place. Anything else you care to do? I know there's a 12. I can't hear you, Ashley.
Well, I don't understand how to run or what.
Well, if you're wrong, you're wrong.
Put the 5x.
Move the X's up top?
Yep.
I got no issue with that. Anything else? Subtract your E's. E to what power? Fifth. And we're actually not done with this. We've still got some cleanups to do. We got x cubed next to the fifth sitting right next to each other. 12 e to the fifth, x to the eighth, and now we can start working on this thing. What is the understood root for a square root? I keep putting that there. I don't know if y'all are or not. Don't be that kid at the end of the year who misses the question on end of course test. Square root of x is equivalent to which of the following? X to the third, x to the fourth, x to the 1/2. You better pick x to the half, right? Look at that too. You should know how to handle the square root of 12. 4 times 3. The root of 4 being a 2, so 2 root 3. You evaluate that 12, you'll have a 2 out front, and leave some space. Still going to have a 3 on the interior. How about the square root of e to the fifth? E to the second on the outside,
With 1
1 on e on the interior. Because when this was taught a week or two back, it was how many times is 2 enter 5, right?
Yeah.
2 enters 5 twice with a remainder of 1. How about the square root of x to the 8th? X to the 4th. Nothing remains because 2 enters 8 4 times, clean remainder. So that was fun. Moving on to F. Does anybody any questions? Nope. Okay. Moving on. How you gonna do F? I'm going to write down a rule. I'm going to write down x to the a over x to the b. You subtract. No, you subtract. X to the a over x to the b is x to the a minus b. That's the rule. A lot of you guys don't think about the rules when it's numbers. But as soon as you introduce variables, that's when you start thinking about your rules. It's a subtraction deal. Just follow that rule. E to the 2x minus 3 minus a what? A negative 2. and then figure out what that is. 4 says e to the 2x minus 1. Enough to name Chris, just like he is. I don't know why it took me so long to figure that out. Just crossed my mind. Everybody okay with that?
Chris.
All right, here's one that's not in your notes then. E to 6e to the 4x minus 5, sitting over e to the 2x minus 2. If you understand subtraction, you probably just do it in your hand. That's the big thing. When you see division, you think subtraction. And just as soon as you think you start getting exponent rules down, we go into logarithms, which are their inverses, and everything's backwards. Anybody got anything? 6e to the 2x minus 3 is the final answer. If you didn't get that, the deal is we subtract. So we have 4x minus 5 up top, and we have to take away both pieces. You just take away the first piece. You got to take away both pieces. And 4x, take away 2x is 2x. Negative 5 plus 2 is negative 3. I think you guys were scared of G, right?
You can skip it.
I'm going to skip it.
Let's do it.
It's not that bad. I mean, standardized test, you can probably eliminate one answer if you want to. Three. So now instead of 1 and 4, you're down to 1 and 3 choices. Bottom of this thing is a 3. The only thing you really have to concern yourself is what is the cubic root of e to the 3x minus 6? You guys had no problems in A following that rule about division. So what is the cubic root of e to the 3x minus 6? What's that mean? No, say it.
A big e to the x minus 2.
Yes, it is. Good job. Mackie said it's e to the x minus 2, and he's 100% right. See if you can figure out why he's right. Mackie, you're the first one all day. Good for you.
Divided.
He did exactly what you've been told to do, didn't he? However many times the root enters the exponent. And is there a remainder? No. 3 enters 3x, x times. Or 3x divided by 3 is x. 6 divided by 3 is 2. Good, Mackie. All right, done with simplification of e. Ignore that these are even your notes. I meant to cut it out, didn't. So ignore that one thing that I just skipped over. Move straight on over to word problem. Beginning of your notes, I said we'd actually do a logistics model. This is actually a logistics model. When you write equations for things, unless you write them right, they have a tendency to keep growing or getting smaller. Like when you're talking about exponential growth, it grows forever, doesn't it? Well, when you do a logistics model, you actually make it stop. That's what this is. This is a logistics model. And it deals with the length of a tiger shark. This is the length of a tiger shark as a function of its age. And we're going to do everything in a graph. Now the goal here, though, is to do this. The goal here is to figure out the length of a tiger shark who's 3 years old. Does everybody understand that you would let t be 3? Yeah. Okay, we're going to do it entirely in a graph. We're not actually going to plug a 3 in like we usually do. Okay? So something a little bit new to you. I reckon we should go to y equals. And what should we put in y equals? The equation. What's the equation?
337 minus 260.
E again, second natural log. Don't you be hunting on test day for that button? We're not gonna put a 3 in the 1, 2. We're just, because that would be when he's 3 centimeters long. I'm pretty sure tiger shark is longer than 3 centimeters in the 1. I don't know. Maybe not. You're not gonna put a 3 anywhere. Okay, we're just gonna look at that. That's all we're gonna do. How you zoom? 6. You're not gonna see anything. How do you think you should look? Up. Anybody got a rough idea? 337, take away something, isn't it? That means the top of this graph is going to be at 337. So look up like 350, 400. I'll do 400. Window, Ymax, 400. Graph. See what I see. Now, you'll notice it's starting to, the curvature is slowing down. I don't know if you can see that here or not, but the curvature is slowing down. The rate of change is actually slowing as it gets farther up. If you look a little bit to the right, and I'll go out 50 years, change the X-max to 50. I have no idea how long a tiger shark lives, but I'm assuming 50 years old, they're fully grown. I would think. You notice it flatlines, doesn't it? Because this is a real world model. Don't things stop growing? Yeah, they stop getting longer, even fish. Okay? Could you imagine if you never quit growing? I am 42 years old. That would be huge. Absolutely huge. So it flatlines. That's why it's called a logistics model. It takes into account what should happen. Turns out this is about as long as a tiger shark can actually get on average. Now, the goal here is to figure out how long the tiger shark is at 3 years of age, which means we want X to be what? 3. We're actually not going to switch out and plug in a 3. Hit second trace. So second trace. And what's the first thing that's highlighted? Value. That's what you want to use. What do you want X to be? 3. This might be quicker in some cases than using the storage feature. You're supposed to plug things in. You just look at the graph and use that value function. Anyways, when X is 3, roughly how long is the tiger shark? Centimeters, not feet. Did you say foot? That's a big shark. It's a huge shark. Oh, Lord. 175 centimeters. All right. Determine the age of a tiger shark that has a length of 220. I don't want to do this with you right now. You know how to do this, don't you?
220 equals.
220 equals, right? Yeah, I'm going to skip over that one. We need to for Charlotte's sake, but we're going to do it at least once more, I think. All right, so last week you learned the formula for compound interest. What was she?
Okay. A sub t equals a sub 1.
No.
No, sorry, that's the other thing. Hold on. P times
R. 1, yes, plus
R over N to the N of T.
that little formula compounds interest so many times per year. If it says compounded quarterly, you put a 4 in. Compounded monthly, you put a 12 in for N. There's another formula out that they say is used in money. It's not in the real world. It's the continuously compound interest formula. It compounds interest an infinite number of times over the course of a year. Kind of hard to understand. But it's easy. The amount after time passes is the principal times e to the RT. Pert, which used to be a pretty popular shampoo. For some reason, they say this is used in financial aspects. It's not. We teach it with money because if the kid doesn't like money, what else are they gonna like? So we teach it with money. Its true use is anything that obeys or follows uninhibited growth. That's its big use, uninhibited growth, which I guess money could grow uninhibited. Invest properly, it could. But anything that follows the law of uninhibited growth. So there's keywords to know about this formula. First, the most obvious is continuous. The second one is uninhibited. You see those two words, you're going to use PERT. Plain and simple. Those two words show up, the formula is PERT. And let's do the two things that require PERT. You deposit $5,500 into an account that pays 8% interest compounded, and there she is, continuously. How long will it take to double? Again, because you saw the word continuous, what's your formula? PERT. Now, you have a goal. You want to double your money. You have $5,500. What's it going to become? 11,000. What is that? In that formula, what is $11,000? No.
It's what it's.
It's what it becomes. You guys see, the problem is you guys still you say AT, you say A sub T. What do I say? Amount after time. It's the A sub T, amount after time passes. 11,000. What's the P? Principal. 5,500. E, what's R?
0.08.
0.08. You move that decimal 2 positions and then a T, the unknown, because that's what you're trying to get. And we will do this one. All right? Where are you going to put that 11 grand? That Y1. Where are you going to put the 5,500 E? Y2. You guys ought to be getting really comfortable with this by now. Sadly, Charlotte and her sister had never used a TI-84 before, so you guys, you're all new to this. I know that. I about screwed up. 11,000. Yeah, you'll need to go up a little bit. Next week we'll get started. I think maybe towards the end of next week we'll learn how to do these things by hand. I mean, for what? For why? Because I'm trying to create engineers, and engineers don't just push buttons in a calculator that rounds. No, he's an RN. All right, zoom out. 6. And nothing. Are you surprised?
No.
Why aren't you surprised?
Because they just 11,000.
11,000. What do you want to set your window to?
15.
That's enough. 15,000. So Y max, $15,000. And then graph. Set a Y max 15,000. Graph. Yeah, no, you better cut it off. Second trace what? 5. How many times you press and enter? Enter, enter, enter. You get about 8.66 years. You get that, Charlotte? 8.66. You haven't done second trace 5. Second trace intersect, that's what I'm saying, 2 times. About 8.66 years. Be a lot more, you guys need to consider this. If somebody gives you some money, you inherit some money, 20 grand or whatever, you can blow it and you can invest it. Right? You leave it alone if you're set for retirement. Well, at least you have a darn good start. The issue is leaving it alone. Invest it. All right, here's a better use for PERT. If you were to run an experiment and you gave a bacteria culture an unlimited amount of resources, it would grow forever and ever and ever. You understand that? All right, so a bacteria culture grows at a continuous rate of 1.35% per minute. If there are 3 bacteria present now, part 1, write a model.
Okay.
You need a model. And I do see, by the way, the word continuous. So it's all about PERT. What's P? 3. The amount of time passes is 3. E, what's R? 10135. A lot of kids, when you talk about 1.35, will write 0.135. And then T. Now, in the text, this was a per minute deal. The model that you now have does on per minutes. If I asked you how many bacteria you had after 3 hours, what would you plug in? 180. You get that? It means you took the 3 and you multiplied it by what? 60. So how does that help you do part 2?
Put T over 6.
Not over. You took the time and you multiplied it by
So
60
T times 60.
T times 60. To do part 2, you got to do exactly what you know you would do if you were inputting hours. You have to take that exponent and you have to multiply it by a 60. No, that's kind of hard to read. 0.0135T and then a 60. And figure out what 60 times 0.0135 is. And that will be an hourly model. There you go, it's 0.81. And you now have a model that accepts hours instead of minutes, or returns hours instead of minutes. And then we have part 3. To the minute and second, when will there be 1,000,000 bacteria? You want to use the model that deals with returning minutes, or the model that's going to return you hours? Hours. Less work to do, isn't it? Use the hourly model. I'll be so glad when we get to logarithms and I can quit doing this whole y1, y2 crap. Anybody else tired of y1, y2? You like it because it's easy. I am tired of doing it. I hope you understand it by now.
Oh, yeah, I understand.
Whoever you're talking to on your phone, I hope understands it by now. You should. You might want to get that thing. Anyways, y1's 1,000,000.
Yeah.
Y2 is the 3e to the 81/100ths of x. Of course you have to go up past 1,000,000. If you put 1,000,000 in y1, you have a horizontal line where? At 1,000,000. I like a 10% cushion when it comes to stuff like this. And I'm actually really lazy here. I would put in 7 ones. That's about a 10% cushion. The reason I like 10% cushion is that gives you white space up top. It gives you clear space. If you do enough of this, you'll understand why you want a good bit of clear space above what you're looking at. So I actually just put in 7 ones as my Y max because that's more than 1,000,000. And then graph. Oh, I don't see much. You have to look over. You're only looking how many years in how many hours in the future? 10. As you go right 10. But you can see it starting to grow, can't you?
Yeah.
And once these things grow, what happens? They go straight up almost. So 10 is almost there. 20 will do it. I think 15 does it. Because once these things grow, they grow. They shoot straight up. That's the definition of exponential growth. And then, for at least my 12th time today, second trace what? Second trace 2. That's an actual function I used to teach. It's the zero function. Use it to find intercepts. I quit teaching it because kids couldn't figure out what left and right was. Honest to God, I quit teaching 3 years ago because I had the hardest time telling them that's the left, that's the right. So now we use intersect. 0, enter, enter, enter. That's hours. That is 15.699874 hours. I'm going to write that entire decimal down. We're just going to work a few more minutes. Is that how I want the answer? No, I'm so sad about it.
Yeah.
I had a lot of kids tell me they've never been taught how to convert from decimal hours into actual units here, so it's worth doing. How many whole hours? You better get that part right. There are 15 whole hours. So I'm going to throw away that 15 in my calculator. I'm only going to worry about the decimal, 0.699874. That decimal still represents an hour. The next logical thing is to turn it into minutes, isn't it? How do you turn that decimal hour into whole minutes? Sure, multiply by 60.
Good afternoon. We only have a couple of announcements this afternoon. The ball game is tonight at Gleason, and tomorrow's dress-up day is dress as your favorite holiday. Hope you have a great afternoon.
Should have thought that clearer. How many whole minutes?
41.
41. Is there?
No.
We're going to take away that 41, and we're not going to say 0.99 minutes. We're going to turn it into seconds. How do you turn it into seconds? Times it by 60. No. If you round properly, that's 60 seconds. Then it was 42 minutes. It may not have been apparent to you when you first looked at that decimal that that actually was closer to a whole minute. Wasn't it?
Yeah.
I mean, that's 59.5 seconds. We're just going to take that minute and round it back up. The decimal is more accurate, but that thing is more understandable, right? I hope you get that. That is something you should understand. Somebody tells you 15.699 hours, you're like, huh? What does that mean? I can barely read a regular clock, much less know what that means. All right, there you go, kids. You got plenty to do. Yeah. Hold on a second. Let me stop recording before I say something to you I shouldn't.
No.